Hey everyone, my name is Daniel Moyer. I'm one of the sales support trainers here at Briggs & Stratton Energy Solutions. Today's topic is whole home backup featuring the Sol-Ark 15k and our batteries. We're also going to talk a little bit about how a whole home backup system will probably want to also incorporate a generator as well. A couple of housekeeping items. This talk is approved by NABCEP. So at the end of the talk, my email is going to pop up. Go ahead and email me your full name, spell it out for me so I get it correct on the certificate, and I'll check the logs and we'll go ahead and issue you the NABCEP certificates. Speaking of NABCEP, NABCEP conference is coming up in March, and it's going to be in Milwaukee, and that's home of Briggs & Stratton. So we're going to be hosting an event before the show, and at our headquarters, we're going to have a museum tour, probably some additional training, catered food and stuff. So if you are going to be attending NABCEP, it's one of my favorite shows. Please let me know, and I'll make sure that we get you an invite to our event pre-show. More sooner than that is going to be RE Plus in Las Vegas. It's next week. And if anybody here is going to be at that show, again, let me know. Either put it in the Q&A. The chat's disabled. Q&A is open. I'll make sure I have a special gift for you at the booth. Really excited about RE Plus. It's one of the biggest shows we have here in the United States, and our booth number is there. Hope to see you next week as well. So quickly, just running through the products. One of our most successful batteries right now is our 6.6. It's on the battery storage at the top left there. You can go up to 3 modules in a stack, so right up to 20 kilowatt hours. What makes that battery so good for a whole home backup, and why I'm going to focus on this in this talk, is that not only is there the limitations of an inverter to power all the loads, but we need to make sure that our battery can discharge or charge quickly enough to support the capabilities of a Sol-Ark or another hybrid inverter. In the case of a Sol-Ark 15k, it can do 12,000 watts from batteries to loads. It can do 15,000 watts to loads if you have batteries and solar. So if you have that 6.6 battery, and in this example, I only have one module, 6.6 kilowatt hours, but if I were to do a 3 stack, which is the most you can do in one stack, it has a continuous discharge rating of 14,000 watts. So a single stack of 6.6 batteries, a 3 stack, is capable of handling all of the requirements of a 15K. Energy track. Now, there is monitoring. Of course, my Sol-Ark is a monitor, but Energy Track is our internal battery software monitoring platform. So it gives you that additional detailed level of batteries, a lot more detailed level than what you'll pull from a Sol-Ark. Maybe you don't need that. That's why we made Energy Track optional as well. Phi and SimpliPhi, these are our kind of legacy batteries, I'll call them. Each one's 3.8 kilowatt hours. The Phi is still available in 24 volts, which is kind of unusual in the lithium ion industry right now. High voltage batteries, these are all wired in series as opposed to the Phi, SimpliPhi, and SimpliPhi 6.6, which all need to be wired in parallel. By wiring them in series, we can support those high voltage inverters, which are able to support 208 3-phase or 480 3-phase as well. Generators, we'll talk about them a little bit more. We have a whole line of air-cooled generators all the way from 13 to 26K. And our liquid-cooled goes all the way from 30 kilowatts up to 200 kilowatts. There may be examples where we do use a transfer switch in a whole home backup situation, even though the Sol-Ark has that built-in MID. And we'll talk a little bit about that as well. So, historically, a lot of the whole home backup systems were generators. Generators were kind of the way we did it before the advent of really energy dense and powerful lithium ion batteries, before the advent of more powerful hybrid inverters that could power an entire home's load and be able to surge to start motors. But some of the drawbacks of generators, right? They consume a lot of gas, either natural gas or propane. If you have a portable, it's either gasoline or propane. that gas can actually cost more than you might think. That 26K I'm showing in the picture at a half load consumes about 2 gallons of propane per hour of runtime. Well, with propane being maybe say $3 a gallon or a little bit less, that's $6 an hour, right? We can be over $100 an hour, $100 a day to run a generator. Additionally, generators, when the grid goes out, boom, everything goes down. It takes maybe 30 seconds to a minute for the generator to start up, make sure it's running good, transfer. By that time, all of your clocks have reset, your internet's rebooting. It doesn't seem like a big deal, but with these hybrid inverters that have millisecond transfer times, most homeowners don't even notice that the grid has gone down, and they're not going to see the clocks reset. They're not going to see the internet reboot. Additionally, with generators, there's that noise and the fumes that come with them, and also the maintenance that comes in. And the maintenance is required whether or not it runs at all. You always have a yearly maintenance as well. But again, we're going to talk about where generators might play a role in a whole home backup situation. Again, Q&A is open, so I'll be checking that as we go along. One thing that's really interesting is the ability to combine both a generator and an energy storage system together. This can be especially important when it's wintertime, and a lot of off-grid homes always incorporate a generator. When there's those long winter storms, solar's not able to produce enough to keep the load satisfied, let alone charge the batteries. We're going to want to start that generators, and these hybrid inverters have built-in 2-wire signal to start that can automatically start the generator at a certain state of charge on the battery, charge up that battery and shut it off. Some exciting news, and we're going to be releasing an RE Plus of other hybrid inverters that can not only have a certain state of charge when we start the generator, but also stop the generator. Some hybrid inverters, when you start the generator, it's going to run a full charge cycle up to usually around 95% stated charge. But I don't always want to run the generator that long. What if it's evening time and I want to start the generator maybe at a 20% stated charge on the batteries? They're getting low. I can run the generator to charge the batteries maybe up to 50% stated charge. I don't want a full charge because I know in the morning, sun's going to come up and solar will finish off that charge of the batteries. So that's a really unique opportunity that not only can we control when the generator starts, but also when the generator stops as well. By doing that, by combining the two, I like to think of it as a hybrid car where we can kind of, use batteries, coast on the batteries, but if we need to go a long distance or we really need to go fast, we can start up that generator, save fuel. A lot of times, if there's a long outage, the propane companies or everybody's calling the propane company to try to get their tank filled. They're not going to be able to service everyone. Maybe the roads are blocked and they can't get the propane truck down the road as well. Again, when you combine them, reduce the fuel, maintenance, and the fumes that come with running that generator as well. Let's check the questions really quick. Verlin, we'll get back to you on the website form. Tyler, can the Sol-Ark handle vehicle to grid or vehicle to home, supplementing the whole home backup from a compatible electrical vehicle? That's a hot topic right now. And if anybody's attended some of John Cromer's trainings, he's the trainer there at Sol-Ark. He's hinted at it a little bit. I'm not sure if they've had complete integration yet, and we'll check with Sol-Ark. But the idea is maybe you have a Ford, one of those Ford F-150s or any pickup truck that has outlets in the bed of the truck. Some of them have 240 volt 30 amp. Some of them are just 120. But we could theoretically bring that in and then use that AC coming out of the truck to go ahead and support loads or potentially charge the batteries as well. The idea that you might be able to take DC directly out of a vehicle batteries, that's an exciting opportunity. The idea that you could then also, charge it DC, that's a really cool one. And I would encourage anyone to attend the NABCEP conference last year. There was a great talk on this subject. We'll have to check with Sol-Ark, but it's really exciting. I definitely like the idea of using a vehicle's battery to provide extra resiliency during an outage. Whether or not we're going to cycle a vehicle's battery for maybe time of use or peak shaving, that's going to put a lot of cycles on that vehicle battery, and there might be some warranty implications. But absolutely, that's an exciting topic, and I'm really excited for that future as well. We show this a lot on our presentations, and I want to just focus in on a few things here when we're talking about whole home backup. We got our grid, and we got a bi-directional arrow here, right? The idea is that the grid could charge the batteries and support the home loads. There's no solar in this picture. There's no generator in this picture. So the only way to charge those batteries and keep them charged is from grid. And if the grid goes down, where the inverter having that built-in MID is going to, within milliseconds, isolate us from grid, and we're going to use energy stored in the batteries to power the home's load. One interesting kind of development, and it's kind of a disturbing development, but we can go either way on this, is the idea that there's no longer favorable net metering agreements. So the idea that that arrow is going to be bidirectional. So if we have solar, batteries are charged, home loads are satisfied, we can start to export that solar to the grid. We used to be able to get a one-to-one credit for every kilowatt hour we inject. We get a credit for a kilowatt hour we can use. A lot of states that are coming in utilities, there's no longer that favorable one-to-one. You're probably getting paid wholesale rate for that kilowatt hour you put back onto the grid. So what we need to do now is we need to use the solar to power loads during the day, charge up the battery, and then at night, discharge that battery to the home's load. So we're doing everything in our power to not use the grid. In a lot of ways, that's kind of the idea of a whole home backup. We're not using the grid to power our homes. Of course, we can always bring in a generator and be able to charge up those batteries if the grid has gone down. Just to recap, when an energy storage system goes down, right, we're going to isolate ourselves from grid. We're going to use energy stored in the batteries to power the home's load. If we do have solar producing, we're going to be able to charge up our batteries and support the home's load as well. Now, it's interesting to kind of see on the left-hand side is that there is, the idea is that you don't necessarily need to have solar. And I've seen it become more and more common where it's just like a giant UPS for your home, where you're going to use batteries. The batteries are only going to last as long as they have juice in them to back up an entire home. That also maybe would result in a smaller solar photovoltaic system that isn't necessarily going to cover your entire yearly consumption of electricity, but a smaller system that's going to be able to just charge up that battery during grid outages. I really am excited for the advent of some of these larger inverters. What really made, now on this slide here, I'm showing both 12Ks, but I probably should change the picture on the right-hand side of that inverter to a Sol-Ark 15K. What made whole home backup possible was the idea of the 200 amp pass-through. So the Sol-Ark 12K on my picture here has a 60 amp pass-through. I think it's a 63 amp breaker, but we can only bring in 60 amps from grid and pass it through to the main panel. But with the advent of these much larger, much more powerful Sol-Ark 15K and other hybrid inverters, we have what's known as a 200 amp pass-through. Most homes have a 200 amp service. We're now able to bring all 200 amps through the Sol-Ark into the main panel so that by default, we're no longer having this kind of critical loads sub-panel versus the main panel. Because if grid goes down, in this example, all of the loads left over here in the main panel are going to drop out, whereas all the critical load sub-panels will stay on. Now, notably, in a time of use arbitrage, right, where during certain times of the day, we want to use energy stored in the battery to power all of the home's loads. With Sol-Arks and some of the other hybrid inverters, we can install CTs here. So we can measure amps coming in and out of the grid, and we can program the Sol-Ark to say, look, if grid's up during certain times of day, I want you to discharge the battery to support all of the critical loads, of course, but also send just enough power back to this main panel so that you're powering the loads here during time of use, but not so much that you're sending any back to the grid. So using CTs, absolutely, we're able to still leverage the time of use kind of arbitrage, even though we're not powering, we're not backing up the entire loads. Here's our 15K, right? So what are we looking at? Right at the center of our screen top is our meter. And then what we have is a disconnect. And what I've seen a lot on the East Coast and other parts is this is how it looks, right? You got a meter socket, you got a disconnect, and then usually in a basement or some other part of the home, you have the main distribution panel. That makes it really easy because all we have to do is intercept the conductors, feed it into our grid port on our Sol-Ark. Coming out of the load port on the Sol-Ark, we go to our main panel. Out here in California, where I'm located, we have a lot of meter main combos, and that can be a little bit more difficult. Sometimes we have to do the Hawaiian tie-in, or we have to lug feed in order to intercept the grid and then send it back over to the main panel. There are some unique ways, and again, Sol-Ark has some other trainings that talk about this as well. Over on the left, of course, we're going to have some solar usually, and part of that we need to have our rapid shutdown. In this example, I'm showing some AP Smart rapid shutdown devices. Built into the Sol-Ark, there's a little DIN rail, a little accessories rail that can power a rapid shutdown transmitter that will send the keep alive signal to that AP Smart, or Tigo makes them as well. Sometimes those AP Smart or Tigos the transmitters draw more power than what the Sol-Ark is capable of producing on that accessory pinout. So sometimes we might need to put in a power supply for the transmitter over here, turning that AC to DC. And then if we do hit the rapid shutdown button, when you hit that, not only is all power coming in and out of the Sol-Ark cut, but that accessory power supply to the rapid shutdown is going to cut off, shutting down our solar at the module level. Or if we've located over here, once the power to the main panel or all the backed up loads gets cut, that transmitter will lose power, shutting off the solar. Coming out of our batteries, the stack, this is our 3-stack here. Again, it has enough continuous discharge to be able to support a solar. And we're going to want to make sure we run our comms, right? These are closed loop communicating batteries, and we need to make sure we enable that. The Sol-Arks do have a built-in PV disconnect. You can see it right there on the left-hand side, but sometimes code or jurisdiction might want us to also install a separate disconnect, and that's an IMO disconnect there. Of course, Sol-Ark has a monitoring app, and the My Sol-Ark is what you see on the right-hand side. Off-grid, and I would even think that even if people have the ability to get grid to their home, there's been a lot of grid defection, and Solar Builder magazine did a great article on this, that at what point does the utility cost so much money per kilowatt hour that I might just forego the entire utility and off-grid a home that otherwise could have grid. It's not some mountain cabin. We're living in the suburbs, and you can absolutely off-grid a home. The Sol-Ark, the generator, and our batteries are all warranted for off-grid as well. This breaker here may or may not be required. The generators do have a built-in breaker in them. A lot of times I've been hearing about 400 amp services, especially down in Florida. In that example, we can parallel up Sol-Arks with the 12K. You can parallel up to 9 Sol-Arks. And I've transitioned away from my 6.6 stacking batteries to these Boss cabinets. These Boss cabinets can hold either the Phi or the Amplify batteries. And we can get up to about 45 kilowatt hours, a little bit over, by having these cabinets full of our Phi or Amplify batteries. And then what we're going to have to do is bring it into a combiner box. Here's a Midnight Solar combiner, but you could also use Victron makes an example, or even doing power distribution blocks as well. But the point being is that we need to combine all of our batteries together and then feed them into the Sol-Arks. And then what we need to be able to do is combine the AC output of the Sol-Ark together before we feed off to our 400 amp service in the home, or bring it into the home as well. So again, you got to combine all the AC, feed them to the Sol-Arks. You got to combine the batteries and feed them into the Sol-Arks. There is some exciting news. Come to RE Plus, you'll hear about it, where other hybrid inverters allow you to have separate battery banks without the need of a combiner coming into the individual inverters. Let's just take a quick look on how we're going to bring in a generator into a Sol-Ark 15K here. So we got our grid, we got our utility, we got our disconnect, and those are our CTs that we'll want to use. They recommend to use them even if you're not going to have loads upstream, just so you have that extra reference. All these ports do have CTs built into them, but they do recommend we bring 200 amps into our grid port. Right out of our load port, we're going to bring our 200 amps down to our main service panel. And then we have our generator here that we feed into the gen port. Easy, right? No need for a transfer switch. But what if we need that gen port for something else? And one way to accomplish this is to actually include a transfer switch. So we still have our grid, our utility meter, and normally this transfer switch, you can see the line here, normally this line is going to be up and down. And so in normal operation, grid's going to be able to come in and out of the grid port, and the load is going to be supported down here, and the generator is going to be isolated, right? Because we're going up and down here. So one reason we might want to have the gen port open is if we have AC coupled solar on site. This is pretty common now, where somebody has an existing Enphase or a string inverter from Solar Edge or the like, and we're going to want to bring that in, right? We want to be able to leverage the AC coupled solar in a grid down situation. So in this example, if the grid goes down, this transfer switch is going to stay in that up and down position. We're going to use energy stored in the batteries to power the home's loads, and also to create a microgrid. And we're going to use a grid forming capabilities of that Sol-Ark to trick the AC coupled microinverters, which would otherwise shut down in the loss of grid, to say, hey, look, grid is here. I'm going to go ahead and start sending AC up into the Sol-Ark to support loads and potentially charge batteries. That's when the Sol-Ark is off grid, it's a grid forming, and it can change the grid form. It can raise the frequency of its sine wave to curtail AC coupled charging when the batteries start to get full. But when we have a generator, we revert back to the grid following, just like the Sol-Ark would if it was following the grid. It sees the grid. It doesn't, it recognizes this generator. So if the batteries start to get low and the solar is not producing, the generator will start based on the 2-wire signal to start coming from the Sol-Ark. The transfer switch will transfer to the example you see here, and then we'll go ahead and send in our generator power to grid, and we'll go ahead and charge batteries and support loads. What can happen though is if the AC coupled solar starts to produce, it can latch on to the sine wave of that generator and start to backfeed the generator. So what we need is a lockout module, some way to say, look, if the generator starts, we need to go ahead and shut off our AC coupled solar. Most of the time, if the generator has to start, right, that's going to be at nighttime or the AC coupled solar is not producing. But there could be an example, maybe during the day, batteries are low, it's a cloudy sky, the generator starts, and all of a sudden those clouds go away, that AC coupled solar starts producing, we can end up backfeeding our generator. So we have to be able to isolate the AC coupled solar. Again, really excited about the Sol-Ark 15k. It's one of the most powerful hybrid inverters on the market. It has the ability to surge up to 100 amps AC to start some of those motor loads as well. And I think the ability for that 200 amp pass through is what's made it possible for these whole home backups, with the ability to also start that generator. And you might have noticed earlier in some of the slides, some older pictures of Sol-Arks that have, Sol-Ark has updated their inverters. We've had a long history, and some of these older pictures are just showing what we've done over the years as well. Battery chemistry has been a big topic over the years. The industry has really moved towards lithium iron phosphate, LFP. Now, there is still some applications for cobalt-based chemistries in our world. Briggs & Stratton not only makes these batteries for home, but we also make electric lawnmowers, electric riding lawnmowers. And those batteries we make in that division are cobalt-based chemistries, NMC. And why would we do that is, cobalt-based chemistries, just like the ones in our phones or in our computers, cobalt is much lighter, it's much more energy dense. You sometimes can have a better ability to charge and discharge quickly. We want that in a mobile application because we want lightweight. But for a stationary battery, something we're going to hang on the wall or put in a home, it's not going anywhere, we're going to leverage lithium iron phosphate. The safety profile of a battery, shouldn't be based solely on the chemistry being leveraged. There's many other factors that go into making a safe battery, such as cell form factor, the battery management system, the cell construction, or the way we package the cells together. And not only on our cobalt-based chemistries, but also on our lithium iron phosphate chemistries, that 6.6 you see there. We have to pass a number of UL certifications that prove the safety of our batteries, and we've had a great success with the lithium iron phosphate. We just upped our warranty, and I'm not sure, hopefully marketing is not going to be upset at me, but we upped the warranty for our 6.6 to a 15-year warranty now. Our warranty is 15 years on a unlimited cycles at 100% depth of discharge with no throughput. Some of our competition might say, a certain number of cycles, your warranty's up, a certain amount of energy in, energy out throughput, your warranty is up, or a certain number of years. We just have that flat year warranty. Now, given that, we do have some estimated cycle lives up there. And, back in our lead acid battery days with our Trojan or the MK Deca batteries, we always, thought of battery life as kind of the depth of discharge as is the deciding factor on how long a battery will last. And that's still true on these lithium ion batteries, but what can affect the life of a lithium ion battery more is not necessarily the discharge state of charge, but the discharge rate. So you can see 0.5 C there, that's a C/2 discharge rate. You're going to get a lot more cycles. 0.75 C, that's like an hour and 15-minute discharge. You're going to get a little bit of a limited cycle. You're going to limit your cycles a little bit. most people don't charge or discharge their batteries in 2 hours, let alone an hour and 15 minutes. Usually you charge the batteries over the course of a day. Usually you discharge them over the course of a night. But if you did really hammer on them, it can affect some of the cycle life as well. Let's take a look at some of the questions here. Ben's asking, does the 6.6 battery stacks need any type of cooling or fan? No, they do not need a fan. Those Boss cabinets do have built-in fans for the Phi and SimpliPhi batteries as well. I would encourage, I go to RE Plus and I'm going to go walk around the show and I'm see a lot of our competitors actually paint their batteries black. And anytime, you put something that's dark colored in the sun, it's going to absorb a lot more heat. And, I got a lot of compliments on our battery for looking really nice. And one of the reasons they look nice is that they got a good, nice rounded kind of form factor to them. They're tall and skinny, but they're got a great color to them. So painting it white absorbs less heat. I would still encourage people to keep them out of direct sun if you can. Especially the Sol-Ark, keep it out of direct sun because you can fry the screen. If anybody remembers Redbox, there's a little flap that covers the screen to prevent burnout. Cold weather, we're going to talk about here in a second as well. Vince is asking, where a generator is employed in the system, would it not be better to use a DC generator to supply energy directly to the batteries? That would better emulate my hybrid car example and would be more efficient. Absolutely. In fact, I saw one of our competitors come out with a DC generator a number of years ago. And so absolutely, anytime you change AC to DC, DC to AC, right, you're running a generator, kicking out AC. You got to send that into the Sol-Ark, which then turns it into DC. Yes, it would be more efficient. I think one of the problems is that there's not a lot of generator manufacturers out there making DC generators, and I have seen a couple at some of the RE Plus. We make thousands or maybe even tens of thousands of generators along with our competition every year, and they're all AC based because they're meant to be used in that example with the transfer switch. So would it be more efficient? Yes. Would the generator, a DC generator, be more expensive and more of a niche item? Yes, just because there's not that many applications for it. But a great point. And yeah, absolutely, it would be more of an example. I think that goes back to the example of a hybrid or the vehicle to grid, right? What if we could take DC coming out of a car battery and send DC into our batteries? Using some sort of DC to DC converter, that's an exciting kind of opportunity. Now let's see if anything else. Ben's asking about the wall mounted or floor mounted. It is both wall mounted and floor mounted, and yes, we're going to put it on a slab if you do have it outside, and I'll show you some examples of that. Yes, the 6.6 is outdoor rated. And we'll keep going. So let's stop here for a second. I mentioned earlier that a stack of 3 6.6 batteries has a continuous output of 14 kilowatts, which is perfect because for a Sol-Ark 15k, you can do 12,000 watts from batteries to loads. So if you're going to have a Sol-Ark 15k and you want to do make sure you can power as many loads as you can, you're going to need a 3 stack. That's the minimum size. The Sol-Ark 12K, right, can do 9,000 watts from batteries to loads. So a 2-stack module would be a great example. And you can scale them up. We can do up to 6 stacks of 3, up to just under 120 kilowatt hours. So kind of what we're talking about here is how many batteries do you need for the amount of power you might expect the home to consume. But just because, I told you that you can use, a 3-stack here will power 15 Sol-Ark, no problem. You might need more energy or more kilowatt hours, which might necessitate a second stack, which is what we've seen a lot of is 2 stacks of 3 6.6s paired up with a single Sol-Ark 15K. And then again, the battery management system, if it gets too hot, gets too cold, it may tell the Sol-Ark to stop charging as well. These Boss cabinets, like I told you earlier, can handle either the Phi or the SimpliPhi batteries. And these ones are outdoor rated. The Phi and SimpliPhi batteries by themselves are not outdoor rated. And we have another version of this where we put 6 batteries, either Phi or SimpliPhi, 6 3.8 batteries on the bottom. And then up top, we put a Sol-Ark 12K up top. That's called the access cabinet. That's actually what you're seeing here, but this can also be full of batteries, and we call that a box. And that's a picture of it there. That's an old school Sol-Ark 12K there. So if anybody has installed one of these older versions, let us know. This just kind of goes to show you how long SimpliPhi batteries and Sol-Ark have been partnering in this industry. And you look, the Wi-Fi dongle here is at the bottom. There's clear openings for some of the breakers. We've been asked if we can put a Sol-Ark 15K in here, and we've tried it. We can't. The Sol-Ark 15K is a little bit larger, and we're a little concerned about the cooling, and especially if that Sol-Ark 15K is processing a lot of solar, it's going to warm up in that cabinet. So we're able to put a 12K in there. If you want to do a 15K, you can do the Boss 6 or Boss 12 and then have the Sol-Ark 15K external. So we want to make sure we allow adequate enough batteries to support that Sol-Ark 15K. Today's talk is whole home backup featuring the Sol-Ark 15K. So that's what I have on our slide here. 12K from batteries. And then as we start to, parallel up our Sol-Ark 15Ks, we're going to need more batteries. So if you have your Phi or SimpliPhi 3.8s, they can do a continuous of 1.9 kilowatts to an inverter, C/2, right? We're going to need 8 Phi or SimpliPhi batteries per Sol-Ark 15K so that we're able to handle that 12K continuous. And then we're going to bump those up as we add more inverters. With the 4.9s, that's an older legacy battery. We're going to need 6, 12, or 17 as we move up. But I think really the best option, it's outdoor rated. It has a great price point, a great 15-year warranty. It's our 6.6. And we only need a single stack of 3, and then we can parallel up the batteries using a combiner, using a Victron, using a Midnight Solar, using PDUs to combine the DC together and send it up to those multiple Sol-Arks. One thing to keep in mind, another reason that I would argue that the Sol-Ark 15K is one of the best inverters on the market for whole home backup, is that if you have 2 stacks of 6.6, right? There's our 2 stacks. You don't need a battery combiner because the Sol-Ark 15K has dual battery inputs. So if we're using this example on the right-hand side here, we got 2 stacks. We're going to have a negative and a positive coming from this battery, negative and positive, and we're able to land them all in a Sol-Ark without the need of an external combiner. But if we're going to have a single stack, what we're looking at over here, we're going to need to do something special. It's not that special, but if you notice up here, the Sol-Ark does have dual battery inputs, but it has dual battery breakers. Now, the Sol-Ark 15K can do 275 amps charge or discharge, right? I think if you multiply that by 51.2, that's where we get our 12,000 watts. If we took our single stack over here and we had a single negative and a single positive, we want to feed both of these terminals here, because if we're going to be limited by 200 amps if we were just to use one breaker. So what we make and other people make are these little fork adapters or little combiners. So they combine the positives and then combine the negatives, and then we would land our single red, our single black negative going over to our single stack of batteries. Another, I think, easier way to do it is to double lug it. You double lug, you have a dual 2-aught red, dual 2-aught black, and you have 2 reds, 2 blacks, and we include a little spacer up here for our batteries so that you land it. You're still going to have 4 conductors coming into the Sol-Ark, and then up top you're going to have the 4 conductors. I find it a little easier to work with 2 sets of thinner cables in that big 4-aught. So a lot of different combiners. Again, I'm just reinforcing that a lot of whole home backup systems are going to have multiple battery stacks. And if you're going to have 3 or more, you're going to need to use some sort of combiner. Midnight Solar has definitely been making them for a long time. Some have the breakers. Sometimes you don't need the breakers as well. And if you do need the disconnects, there is some available. I always love going to the Victron booth at RE Plus because they are, I think, one of the few companies that still has all the different parts and pieces. So it's more modular, right? With Sol-Ark, these hybrid inverters, they put all of the parts and pieces into one box, whereas Victron still keeps with all the different parts and pieces. I think that's why they are great for RV or marine applications, because it's easier to fit these parts and pieces everywhere. And only buy the parts and pieces you need. But what they really like for them is their links power in. And these, what I like about them is that you can connect them together. They have Class T fuses. And if we're looking at this, you notice how we have our positive over here and our negative over here. What you can do is land your negative, or your negative down here and your positive over here. Positive over here, negative over here. So you're feeding this this terminal block from opposite ends, and you're going to get a better resist. You're going to get a better system because each battery is going to contribute equally to the needs of the system, rather than pulling it both off this side. Whatever battery is connected here would be doing most of the work. Additionally, keeping in that concept, make sure that all of our battery cables are equal lengths so that each battery sees the same resistance, especially at high amps coming in and out, that each battery is contributing equally to the system. If you are going to have uneven stacks, basically any stack that is shorter, right? So we got a stack of 2 here, and we got a stack of 3 here. Make the stack that has the shorter number of batteries have a longer cable run. So if this 3 stack here, you have more resistance because you have more batteries to go through, we want to replicate that. And one way we do that is making the battery cables longer going to the shorter stack so that each battery stack is contributing equally. If we made both of these battery cable home runs the same, this stack of 2 batteries would end up doing more work because there'd be less resistance. Quickly looking inside of a Sol-Ark, grid on the far right, 200 amps into that grid, 200 amps into the disconnect. And notably, that is not a service rated disconnect, but it is a load disconnect. 200 amps right back out on the loads. We got our gen port, and that's really what's made these hybrid inverters so awesome, I guess is a good word for it, is that they have this 3rd port that can either do a generator, it could take an AC coupled solar. We can have it be a smart load port where we can drop loads based on the state of charge of the battery. Down below is our neutral and our ground bar. Sol-Ark 15k has 3 independent MPPT inputs with the ability to parallel up strings at the Sol-Ark, so you don't got to get your little MC4Y adapters. Battery CAN bus, that's where we're going to run Ethernet from the Sol-Ark down to our batteries. If you're going to run that Ethernet in the same conduit as the battery conductors, make sure you get shielded Ethernet cable. I think all Cat6 is. Parallel comms, that's where if we're going to have multiple inverters, we're going to make sure they can all talk to each other using Ethernet cables. We talked about our battery inputs, and we talked about our DC breakers already. With the 6.6 battery, the battery power conductors and the Ethernet cables are all on top, in a weatherproof top. With the 3.8s, we're gonna have these. This is the AmpliPhi specifically. The Phi doesn't have closed loop. No open ports, so we're gonna plug one port and then we're gonna daisy chain across going out to the inverter. 2-wire signal to start comes out of the pins 7 and 8 on the Sol-Ark, and it goes to pins 4 and 5 on our generator. CTs, right? You can see where the CTs are run. Your E-stop is going to be B and B, and you don't need a temperature sensor because they're not lead acid batteries. I don't know if anybody's heard of Scott Hunt from Practical Preppers. He's got a YouTube channel, but he also has an online store. And one thing he came up with is this knockout template. So what a lot of people do is they install a gutter underneath the Sol-Ark, and then they stub up in and out of the Sol-Ark. So there's a couple ways to do it. You can measure it. We've dropped a little weight and kind of marked them, but he came up with this little template here that allows you to lay that template on top of a 12 by 12 box, and then just sketch out where you need to do your punches and you get your punch set out and punch them out as well. Keep in mind the Sol-Ark 15k has vents on the top and the bottom, so you need to leave enough air clearance. You don't want to smash this right up against the gutter there. The Sol-Ark 12k has the vents on the left and the right, but they still want a little bit of space as well. We got about 13 minutes left, so I just want to make sure we stay on time here. When you power on a system, the best way, the proper way, and if you go and read the Sol-Ark installation manual, right, it talks about first, let's check all polarities of grid, of batteries, and voltage to make sure we're all in range and solar. We're going to turn the batteries on first. We can then turn the Sol-Ark on. Then we can turn on grid and loads and PV. When we're shutting things off, right, we want to it's kind of the reverse order. Shut off PV, shut off the AC coming in and out, shut off the inverter, then shut off the batteries. So the battery is usually always first on, last off, is the way I like to think of it. You don't need my Sol-Ark app because the Sol-Ark still has a screen, and you can see a lot of parameters there. And you hit this gear icon. A lot of the parameters will be auto-populated by the batteries communicating. For example, the battery capacity should be auto-programmed. But there are going to be settings that you do need to adjust. For example, when you want a grid charge to initiate or when you want a generator charge to initiate. But a lot of these other parameters like the float, absorb, equalize will be auto-populated. Quickly on the generator, if all of our generators have a built-in exercise function, auto exercise, we call it eco size. But the Sol-Ark does have the ability to exercise. I would recommend disabling this by changing the time to 0, and you'll let the generator exercise itself. You select Gen Force and hit OK. That will test the 2-wire signal to start. The generator should start up. Make sure you check BMS lithium bat 00 and activate battery and use the percent charged as well. This is adjusting the point at which the Sol-Ark will stop supporting loads based on the state of charge of the battery. Now, I said earlier, you can do 100% depth of discharge on the battery. I would recommend you have the loads shut down when the batteries get to about a 20% state of charge. So at 20% state of charge, the Sol-Ark is going to shut off loads. Before it does that, it's going to give you an alarm at about 30%. And the reason I leave 20% is, yeah, it treats the batteries a little bit nicer, but you want some juice in the batteries to run the Sol-Ark, the parasitic load of that Sol-Ark, to keep it on so that when the sun comes up, the batteries start to get recharged or grid comes back on, the Sol-Ark is still functioning. Then once that does come back on, it's going to wait till the batteries are till about 40% before it starts to turn on loads. You can lower this shutdown a little bit if you want. And this is, talking about bat resistance, that's going to be automatically populated for the 6.6. Here's a little bit of math if you're using our fire amplifier. One other reason that I really like the Sol-Ark and a lot of these hybrid inverters is what's known as PCS or CRD control. So remember earlier I gave you that example of a meter main combo. Let's use this, Sol-Ark 12k. Well, we want to be able to take 60 amps from our load center, non-backed up loads, and pass 60 amps through the Sol-Ark down to a critical load subpanel. But NEC code, specifically the 120% rule, says that if we have a 200 amp bus with a 200 amp breaker, the largest backfed breaker we're allowed to put in there is 40 amps. It's really exciting that there's now UL listings and the ability for these hybrid inverters to say, look, I'm going to go ahead and install a 60 amp breaker, and I'll be able to draw 60 amps and feed it through, but Sol-Ark never send back more than 40. And that's where the setting would be right here, grid cell. Some of these other settings, right, we're going to do this if we're going to be able to limit the power to home, or we're only going to keep it on the load center, and then time of use as well. There's a great link right here that John Cromer does on how to set up this time of use. This is a little bit outside the scope of today's talk as well. Absolutely, you can do 3-phase with the Sol-Arks. And I really like the example of doing AC coupled. Somebody was asking about pads right here. You do have a couple of pads right here. I'm frankly surprised that these SolarEdge inverters are even still operating, but they are. I imagine in here there's two 20 amp breakers, and we might be lug feeding off of that, and we're feeding into the gen port on this Sol-Ark right here. There's our energy track, which gives you that extra level of monitoring. Also, the ability, if we ever needed a tech support, it allows our tech support to remote in. You can use this energy track kind of as a service tool if you wanted, and it is optional. This is also I'm not sure, but I imagine they have this EV charger on a smart load output as well. Off-grid on the left here is left bottom picture is a great example of 80 kilowatt hours of storage. We're combining all these batteries together in that midnight solar combiner, and then we're feeding them up to these two Sol-Arks. This is an off-grid home, which is whole home backup, right? If you're off-grid, you're always backing up the whole home. We do have a generator on this site, and there's a substantial solar array. What's exciting about Sol-Ark and our batteries is that a lot of our competition has the battery and the inverter together in one box. And what that means is that if you need to add more energy, right, you need more capacity in kilowatt hours, every time you add a battery, you have to add an inverter because they're together. Likewise, if you wanted to add more power, you need more inverters, you have to add a battery every time you do that. Where if we decouple the batteries from the inverters, we can add more inverters and keep one battery, or we can add more batteries and keep one inverter. I'll point out in this picture on the right here, this box up here that looks like a grid bypass, which is always a great installer kind of tip, that if you ever needed to service the system or the system ever went down and the power wasn't passing through the Sol-Ark, we could bypass the entire system. We could have a system bypass. Another installer tip is, I like how this person painted the conduit. I think that was a nice touch here for the Sol-Ark. What I don't like here is that these conduit boxes are touching the bottom of the Sol-Ark, so they might have some, I don't know if the gutters come all the way back, so they may be good, but keep the space up and down on the bottom. Wall mount, you can do. If you are going to put them in a garage, make sure you think about whether or not you need parking bollards. You can do a nice system on the right-hand side here. I see some exposed battery conductors here. By code, this is 48 volt nominal, so you're allowed to do that, but I would always encourage installers to always have them in conduit. They're not as heavy as some of our competition. They're 130 pounds each. So you can see here, this is a wall bracket, and then these are the wall base and then wall brackets, and they stack on each other. They're held together with little tab screws and side screws to keep it all together. One thing I like too is portable generators can be used. Portables need to be a 240 volt. You have to manually start and stop the portable. You would have to wait until the Sol-Ark has reached the programmed set point for when a generator should start to start the portable. What I mean by that is if the batteries are full and the loads, the batteries are full and you start a portable, it's not going to do anything. But if the batteries have drained to the point it's below the state of charge that the Sol-Ark would otherwise send the 2-wire signal to start, you start that portable generator, it will then start to charge the batteries and supply loads as well. Here's a couple examples of some Phi and SimpliPhi batteries. We still sell a lot of these. You could either put them in that box cabinet, feed it to that Sol-Ark, or the access cabinet in the middle, or frankly, you don't even need a box at all. I'm hoping that all these green power battery cables are the same length, and we got a nice power distribution here. I'd almost like to see this red right here in the middle. That way we're drawing off that battery combiner there equally. Talk through some of them. Again, the SimpliPhi has a 15-year warranty. I need to update my slide. 6.6 now, 15-year warranty. Phi, still 10, and then the high voltage. If you have any questions about that, let me know, and I'll put you in contact with our team. There's experts in here that understand this a lot better than I do as well. But you can really scale up on these Phi systems. Again, I like that the black over here is coming off this side, red over here on this side as well. For the sake of time, we only have about 2 minutes. I'm going to skip ahead really quickly. Just keep in mind that batteries, any lithium-ion battery, does not do very good in cold temperatures. The Phi and SimpliPhi batteries have heaters on them if you absolutely need it, but our 6.6 battery has some optimized electrolyte between the anode and the cathode, where it can go down to 14 degrees Fahrenheit internal battery temperature and still operate. What I like about that is that it avoids the need for heaters in most applications. If you live up in Milwaukee or really cold places, think about putting them in basements or in garages. If you can't, keep in mind that you could also use our heaters available on the Phi and SimpliPhi. We do have some rebate programs. Our IQ installer program will get you $100 back for every battery purchased, $500 on your second install. If you have an installer batteries, you can get $1,000 off your first install. You don't have to be part of the program for that. There's a QR code. Well, I want to just say thank you to everybody. If you need your NABCEP certificates, energy storage training at basco.com, energy storage training at basco.com. Email me and I'll get you the certificates. I'm going to go ahead and take a look at our Q&A. If you have any questions, go ahead and pop them in now as well. So Tyler's asking, I've been seeing quotes for battery backups, and they all seem to want the batteries mounted very close to the service panel. On my home, the service is on the south side, gets a lot of sun. There's no room to put them there because of windows. Can I put the batteries in the Sol-Ark in my garage about 20 feet from the service panel meter? Yes, you could do that. It's going to cost you in the copper, right? Because you're going to have to intercept the service, bring it over to the Sol-Ark, and then bring it back over there to feed the panel. There is some other solutions, and stay tuned that where you have this other box essentially that allows all AC in and AC out, and then we can put the inverter and battery somewhere else in the home as well. So yes, you can do that. And the reason they're asking that they're doing that for the quotes is to save you on the conduit and copper runs for having to run your home service over and then back again as well. Chris, give us, you're having some problems with SOC not reading right. Give us a call, tech support, ESS Tech at basco.com will be able to help, or you could get on our website. One thing I really am proud of is our tech support and how responsive they are, and they pick up. I know I've been an installer at one point, standing out in the rain on hold for tech support. Having a responsive tech support is really key, right? There's a lot of batteries out there on the market. It's not just obviously the products matter and the performance, but also how responsive we are for tech support, warranty support, is where Briggs & Stratton really shines as well. What does activate battery check do? I've read that it should not be checked and not checked. What it does is that if the battery goes into, for whatever reason, the battery gets drained all the way down and it goes into kind of a protective state. If you check activate battery, then we're talking about some of the programming screen. I showed it briefly. If you check that and hit OK, if the Sol-Ark gets grid coming to it, it will tell the battery via the CAN bus communications that, hey, I've got power again. I'm able to charge you now. Go ahead and activate yourself. So some people may not to do that because you want to figure out what happened. If you properly sized and programmed the system, you shouldn't really be draining the battery to the point where you need to activate battery as well. Can you provide the NEC citation that exempts 48-volt nominal conductors? I got my 2020 right here. I will have to look through that and find that, but the rules changed, and that's why I think at 50 volts nominal, a lot of the rules changed, and that's why we in the industry have stuck to that. I can take a look for that. I'm not going to flip through the tabs right now, but I'll take a look for that, Will, and get back to you on that. So thank you, everybody. Again, if you're going to be at RE Plus, let me know, and I'll see you guys everyone at the booth. Take care.